So once again, welcome back to statistics. We're going to discuss something on a parametric test called the t-test. Okay, so before that, we know that in statistics, you will come up with problems that you have to verify and then try to prove or support, or let's say go against. And then the only tool or the appropriate tool that we mostly use is the hypothesis testing. Alright, so we use the hypothesis testing, and then this hypothesis testing, it's either you are going in the way of parametric or in a way of non-parametric. Okay, so either you go in this direction or the other direction. So you will do parametric statistics or a non-parametric statistics. Alright, and then these parametric statistics are based on the fact that the data sets are continuous and then satisfied some assumptions. Okay, so if you are new to the course, then probably you might not know those assumptions. So but before any data points or data sets would qualify to be studied under parametric statistics, then that data set should first of all be continuous. All right, should first of all be continuous in a sense that on this number line, all right, from 0 here, positive infinity, and then negative infinity. Right, so within this range is kind of going to take any value in this range. Okay, so any value at all the continuous can take. So if you have a variable that the measurement can take any value on the number line, then that data point is known as continuous. All right, so if the data point is continuous, all right, it's okay, then you can go ahead and use parametric test. Right, so if it is discrete, you can as well do that. Okay, so if it is discrete too, you can as well do that. So it can either be continuous or discrete. Okay, so continuous or discrete. So you can put this together and say that it has to be a quantitative data. Okay, so collectively they are all called a quantitative data. So you can collectively call the continuous and then the discrete, put them together, and then that will be a quantitative data. So when your data is just quantitative, that means it is quantified, then you can just straight away go and use parametric statistics, for the reason that they satisfy the assumptions for parametric statistics. Because under parametric statistics, we've done a lot of assumptions. The data set should follow a certain distribution, and then there should be some constant variance among stuff. So these are just deeper statistics. So when your data point is continuous or quantitative and they don't satisfy any of the assumptions for parametric test, then you go in for a non-parametric test. All right, but if the data set is qualitative in the sense that they are just labels, names. So it's like example, you just collected data on their sex. So somebody say I'm a male, female. So that one, there's no number, they are just names, labels, categories. So the appropriate hypothesis test is a non-parametric test. Okay, right. So for a two sample t-test is just a typical example of a parametric test. So the t-test is a typical example of a parametric test. Okay, so a typical example of a parametric test. So it's a typical example of a parametric test. So if you want to do a parametric test, then you can look at the t-test, because it's one of the parametric tests that you can do. All right, okay. So now just an intro. Okay, so this procedure provides several reports for the comparison of two continuous data distribution, including confidence interval, so, and then in the means, two sample t-test, the z-test, the randomization test. So these are all tests that are under hypothesis testing. All right, so but the one that we are much interested today is to looking at the t-test. All right, t-test. So now when we say the t-test, what we're trying to do is that we have two distributions. Okay, so let's say distribution 1 and then distribution 2. So let's say we have distribution 1 and then distribution 2. So remember that when we say distribution, it comes from the fact that there is a certain population. You went in and picked a data point and you try to see the frequencies and then the outcome of whatever, and then you try to create a distribution. So let's say this is the distribution. Let me draw it. This is a distribution for the sketch for the distribution for that of distribution 1, and then this will be a sketch for that of distribution 2. So what this t-test is trying to see that, okay, are these two distributions the same? Okay, are these two distributions the same? So this could be let's say performance of, let's say, university lecturers and that of technical university lecturers. Okay, so these are the distribution for the performance of university lecturers and then the performance of technical university lecturers. So you have these data points, but you want to see whether can you compare these two things. Can you compare this and that and say that, oh, they have something in common? Are they the same or they are different? Okay, are they the same or they are different? So then you have to just be able to test this and see whether they are the same or not. And then the appropriate tool to do that is the t-test. Okay, so the t-test will be able to tell you that yes, indeed, there is no difference in this distribution. So invariably you are trying to say these distributions are the same. All right, so in statistics, instead of saying we are testing for the distributions, we'll go ahead and test for the means. So we'll say that this has a mean 1, and this is the mean for distribution 2. So we'll try to see whether the distribution mean for 1, all right, is the same as the distribution mean for 2. All right, because we believe that if the means are the same, then the distribution should be the same. Because if the means are the same, remember that the mean of any data set is kind of in the middle. Let's take it like that, just concentrated in the middle, somehow like that. So if the distributions, their means are the same, then if you draw them together, one will overlap the other. So that means they will just fit in perfectly, and then the distributions will be the same. So we can go ahead and say that at the end of our test, we found out that the university lecturers, their performance is the same as that of the technical university, because we saw that their means are the same. All right, because we saw that their means are the same. But if fortunately we do the test and then we conclude that the means are not the same, then we can say that here, per the data we have there, we cannot conclude that the distributions are the same. That means their performance are the same. All right, so means university lecturers performs differently from that of technical university lecturers. So it's a very nice tool. So you see, this is a practical problem, but with the help of a t-test, you will be able to try to solve this problem. Okay, so that's just an intro to the t distribution, so take note of that. Make sure you subscribe to the channel, hit the like button, alright, and then turn on the notification so that when I just send any video or upload any video, you would be able to access that video and then move with me. Alright, so